Hello guys, welcome back all of you. Okay, so if I ask you what are the reasons for the causation of seasonalities, what are the reasons or what are the reasons for the causation of the seasonalities? First of all, I've told you very clearly that is nothing but angle of tiltation. We'll be discussing that Earth is little bit tilted, so that is nothing but angle of tiltation. Angle of tiltation is the first reason. So then after that one, the spherical shape of the Earth. The spherical shape of the Earth. So this is also one of the reason, because of what? The amount of the quantity of sunlight that is falling on different parts of the Earth's surface. So the second thing is spherical shape of the Earth. And the third thing is unchanging parallel orientation. Unchanging parallel orientation. Okay, so what is the meaning of this unchanging parallel orientation? So that means, see guys, for suppose just imagine this is the spherical shape of the Earth. So this is a axis. This is the Earth's axis. For suppose Earth is located in its movement. For suppose just imagine the location of the Earth is at this place. So here also the axis will be in the same direction. Means this axis seems to be parallel to this axis, or else just imagine the location of the Earth is some different part of the solar system like this. So here also the axis will be in this manner. So the thing is that the Earth is moving completely spherical, in its orbit around the sun. In different places the Earth is changing its position, but the axis is the same everywhere. So whatever the point you take, the axis seems to be parallel to each other. So that is why I am calling this as unchanging parallel orientation. Okay, so the next thing is unchanging parallel orientation. So this is the third reason. And the next thing, what is the fourth reason? So the thing is that actually rotation of the Earth. Rotation of the Earth. So if I tell you more clearly, first of all we will be considering this rotation as the first reason. Okay, so rotation, apart from that one, revolution of the Earth. So rotation, revolution, so unchanging parallel orientation, spherical shape of the Earth, and angle of tiltation. So this is the axis. So this one I am calling this as axis. So these are the reasons for the causation of the seasonalities. Okay guys, so now let us discuss one more reason. So I've told you very clearly, for suppose just take my hand, I'm just focusing, or else I'm just trying to focus or light the particular light on my hand. So this is a torch light. I'm just trying to focus this light on my hand. If my hand is exactly perpendicular to this torch light, so the light will fall at particular place like this. If I start bending my hand, so the light starts scattering, means it will cover more area compared to the previous one. Okay, in the first case, my hand is exactly 90 degrees or else perpendicular to the light. So the light is falling at one particular place in my hand. So the entire light is focused or else concentrated on one particular area. So that is why, so the intensity will be more around this place. But when I starts bending my hand, the light will be falling in the same area, and apart from that one, it will also fall in the another area. Means the area where the light is falling, that will be increasing, but the intensity will also be decreasing. Why? Because here the distance is less, here the distance is more, and moreover it is bending. It is not a direct light ray that is falling on a particular area. So that is the reason why whenever I am bending, so the light ray will also be starts spreading, and also the intensity will be very less. So that is the thing. So if we take the example of a spherical shape of the Earth surface, okay, like this. For suppose a light is falling over here, it will focus, or else it will fall very effectively and more concentratedly. Similarly, just imagine the light is falling over here. Similarly, the light which is falling over here. So here the light starts little bit bend. It starts little bit bending. So that means the intensity will be decreasing more and more. The same thing is happening with respect to the Earth surface. If you just imagine, this is the equator, and from the equator you are going to the upper latitudes, there you can able to see the bending of the Earth surface. Because of the bending of the Earth surface, the sunlight will be there in the higher latitudes also, but the intensity will be more or less. So I'll tell you an example. In your childhood, you might have played some playing which is with the help of a convex or concave lens. You are putting some paper in front of a concave lens and just you try to focus the sunlight on a particular paper. When you just focus in a manner so that it is very less in a particular very small pointed point where the light is falling, it starts burning. But similarly, when you move here and there, when the place where the light is falling, the area is increasing, then the intensity will also be very, very less. It will not start burning. But when the entire sunlight is falling on a particular area, at one particular area on the paper, it starts burning. In the same manner, so if the entire light is focusing on one particular area, the intensity will be more. But if the same entire particular light is falling on the different area, same quantity of light, but the intensity will be less. The same thing. If the light is falling on the equator, the intensity will be more. If the light is falling on the Tropic of Cancer, the intensity will be less. If the light is falling above the Tropic of Cancer, the intensity of light gradually decreases. So if you take the higher latitudes, that is at the poles, the light will be there, but the intensity will be very, very less. So this is the thing which I would like to tell you. And one more thing, this is the first point which I would like to tell you, because shape of the earth, how the shape of the earth surface is impacting. In the previous video, I have told you very clearly what it is happening over here. And the next thing is that, for suppose guys, just take the example of a summer. Just take the example of a summer season. If I ask you, for suppose summer season, 7 a.m. in the morning, 7 a.m. in the morning, you can able to see sunlight very clearly. Yes or no? In the 7 a.m. itself, you can able to see sunlight very clearly. Even in the night time, 7 p.m. also, you can able to see sun almost all, you can able to see the sunlight is present because it is the summer season. So that is why more amount of daylight you can able to experience. So here you can able to see more amount of daylight. So that means, for suppose in my example, just take the example, 7 a.m. to 7 p.m. almost all 12 hours will be present. 12 hours daylight you can able to experience. And similarly, for suppose even 6:30 also in some places you can able to get the sunlight. Even 7:30 also you can able to see sunlight more or less near to the equator. So there will be more and more amount of daylight. So again, I'll tell you one more example. Just take the example of a winter. Just take the example of a winter. In the winter season, sometimes 8 a.m. also, you will not be able to see the sunlight. In the winter season, sometimes 6 p.m. only. By the end of 6 p.m., by 6 p.m. only, we can able to see that there is no sunlight, completely darkness in your surrounding. That means in winter time, the daylight is very, very less. In the winter time, the daylight is very, very less. In the winter time, darkness is more, light is very, very less. In summer time, daylight is more, and the night time is less, So by this example, we can come to a conclusion that at a particular place, the length of the day and the length of the night is not same everywhere. For suppose take the example of a Hyderabad. In Hyderabad, in summer season, the duration of the day is more. In Hyderabad, the duration of the day in the winter season is very, very less. Okay, in a particular day, the duration is varying. Why the duration is varying means the time during which the sun is able to focus its light. So that is the thing. When the earth is moving here and there, so depending on that moment only, the amount of sunlight that is falling on a particular place will also vary. So I'll just tell you one more example. So if you understand this one, now if I draw this one, earth surface, just imagine this is the equator, this is Tropic of Cancer, this is Arctic Circle, and this is top one is 90 degrees north. Just imagine. For suppose, I'll just tell you I'll just show you an image so that you can understand that one very clearly. I've told you rotation and revolution is also one of the reason which is making you to cause the seasonalities. See now here the earth starts moving. See, this is the orbit of the earth. See, this is the earth. Earth is moving around the sun. This is the rotation. Earth is moving around itself. This rotation is also the reason for the causation of the seasonalities. So, rotating, apart from rotating, it is also moving around the sun. That is nothing but the revolution. See here, winter season. So, that means North Pole is completely under the darkness. South Pole is completely under the sunlight. Okay, see, this sunlight is able to focus over here. So, here is more sunlight. Here it is completely darkness. So, that means whatever the time, see, earth is rotating after 24 hours also, you cannot be able to see the sunlight over here. So, that is the thing which is happening over here. And now you can see two places, North Pole and South Pole. Both of them are under the sunlight. This is another example. North Pole and South Pole are under the sunlight. I'll tell you by drawing the image in a manual manner, but before that you just see that one. Now see, exactly reversal is happening. North Pole is completely under the influence of the sunlight. South Pole is completely away from the sunlight. Even though earth is completely rotating 24 hours, complete rotation, in spite of that also sunlight is not able to fall over here. Getting my point? So that is why this South Pole will be completely in the darkness and North Pole will be completely in the sunlight. So that is at the time of summer. Again it will come, again you can able to see one more equinoxes. Previously South Pole is completely under the darkness. Now see, South Pole is slowly, gradually it is getting sunlight. It is completely under the influence of the sunlight. So here you can able to see sunlight and there also you can able to see the sunlight. So this is what is happening. This is the example of a January. See guys, for suppose see, this is the earth surface. This red color one is the axis of the earth surface. Sunlight is falling in this direction. See, the sunlight is directly falling at a particular place, that is over here 23.5 degrees. In remaining places sunlight is not falling directly, not directly falling, but it is completely little bit slant or else it will be little bit obliquely. See, angle of the sun is falling directly over here. See, this is the South Pole and this is the North Pole. North Pole, see this one here, this red line is the South Pole, this red line is the North Pole. This is completely under the sunlight, this is completely away from the sunlight. So that means 24 hours you can able to see darkness over here and here 24 hours you can able to see sunlight. So what it is happening, I'll just tell you example. Some people will also be having doubt, sir, when the sunlight is falling in this manner, after reaching this place, why don't the sunlight passes in this place also? Why don't the sunlight starts bending over here? So there is a property for the light. What is the property for the light is nothing but rectilinear propagation of the light. Rectilinear, that means a light always travels in a straight line. Whenever it is experiencing some opaque substances, it gets reflected, but it will not pass through that one. Similarly, when the sunlight is falling up to here, it will be present up to here only. It will not try to pass over here like water. Okay, so this is one property of the light. So that is why every time half of the earth surface will be under the sunlight and half of the earth surface will be in the darkness. Again the changing will be happening gradually. Okay, so now let us see, this is the position of the sun and this is the position of the earth surface, and similarly this is the position of the earth surface at one point of time, and here also this is the position of the earth surface at one point of time, and this is the position of the earth surface at one point of time. I am drawing the axis with another color. Just imagine, this is the axis of the earth, this is the axis of the earth, this is the axis of the earth. Okay, so this is the time period, that is December. Let us consider this as a December 21 and 22. So this is the time period, that is around March 21, 22. And this one is June. This is at the month of June, 21, 22. And this one is the September. Here also you can consider 21 and 22. See guys, in some books you can find this as a March 23rd, you can find this as a September 22, doesn't matter whatever the things it may be. So this is the sun. Just imagine sun's rays is falling over here. Say for suppose this is the earth, this is the axis of the earth, this is called as a Tropic of Capricorn, and this one is called as a Tropic of Cancer, and this one is called as the equator. Okay na? So I'm just writing this one like this, Capricorn, Tropic of Capricorn. So what is happening? Sun's rays is falling. So when the sun's rays are falling, the sun's rays is directly falling at a place which is called as a Tropic of Capricorn, and sun's rays is also reaching at this place, and sun's rays is also reaching at this place. Means exactly this is the part. This half part is completely under the influence of the sunlight. But this part, North Pole, is completely away from the influence of the sunlight. So here you can able to see this Tropic of Capricorn, it is having more amount of sunlight, and this one is the equator. If we calculate at the equator, you just see at the equator, the amount of length of the daylight will be 12 hours. 12 hours is the length of the daylight at the equator. Slowly below the equator, in the southern hemisphere, that is around at, just imagine, Tropic of Capricorn. At the Tropic of Capricorn, the length of the daylight will be around 13 hours. Just imagine there are around 13 hours. Similarly, at the Arctic Circle or Antarctic Circle, at the Antarctic Circle, the amount of daylight will be around 15 hours. 15 hours. Similarly, at the 90 degrees, around 90 degrees, you can able to see the amount of sunlight will be around 24 hours. So this is the one. So means from the equator, the length of the day and light is gradually increasing. In some books, you can also find description in this manner. That is at 0 degrees, at 20 degrees, at 40 degrees, at 60 degrees, and also at 90 degrees. Getting my point or not? So what is happening over here? Okay. So let us completely remove your confusion. I'll just write in this manner. I'll just take the example of it: 0 degrees, 20 degrees, 40 degrees, 60 degrees. So just imagine 0 degrees is the equator at one point of time, that is December 21 and 22. At the 0 degrees, the length of duration of the daylight is 12 hours. So here the length of duration of daylight will be 12 hours. At the 20 degrees south, so the length of duration of the daylight will be around 13 hours. The length of duration will be 13 hours. Similarly, if you take the example of 40 degrees, the length of duration at the 40 degrees will be 15 hours. Similarly, at 60 degrees, that is around 18 and a half hours. And in 90 degrees south, you can experience 24 hours of daylight. So that means the places, the examination, the questions can be asked. They will be giving you different places. So one is located at 20 degrees, one is located at 30 degrees, one is located at 40, 50, etc. So the places which are away from the equator will experience more length of day during the winter solstice. So that is on the December 21, that is the winter solstice. Then what about above latitudes? That means, for suppose if you take 20 degrees north, what is happening in the 20 degrees north? So here the length of daylight will be 11 hours. And for suppose if you take 40 degrees north, the length of daylight will be 9 hours. Okay. 60 degrees north, just the example of 60 degrees north, the length of daylight will be 5.5 hours. And at the 90 degrees north, the total length of the daylight is 0. That means, see, from 90 degrees south onwards, 90 degrees north, the length of the sunlight is gradually decreasing. The length of duration of the sunlight is gradually decreasing. Okay. I'll just draw only this December solstice in a very clear manner. See guys, this is the earth. This is the axis of the earth. Okay. Just imagine, see, this is the equator. I'm just drawing like this. This is the equator. And see, this is the Tropic of Capricorn. This is the Tropic of Capricorn. And see guys, this is the Tropic of Cancer. And this is the location of the sun. So when the sun is able to focus or else release its light, the highest light means the place where the sunlight is at highest peak, that is at this point, that is nothing but the Tropic of Capricorn. See, here also the sunlight is able to fall. Here also the sunlight is falling. But the thing is that the intensity of the sunlight is very, very less over here. Similarly, so up to here, the intensity of the sunlight will be more. So that means around, see, up to this point, I'm just writing like this, up to this point, the sunlight will be present. And this point, completely there is a darkness. Again, after again it is moving in this direction. See guys, don't imagine the earth will be moving in this direction. Earth is moving in this direction because the axis is over here. So in this manner, the earth is moving. So that means this is the 90 degrees north and this is the 90 degrees south. So whatever the thing, earth is moving 24 hours, but usually this place is continuously it is having 24 hours. See guys, definitely people will experience some kind of dilemma over here. Why you people will be experiencing dilemma is because we always imagine with respect to our location. Generally what people is having a belief means this is the location of the earth. So exactly half of the earth will be having sunlight and remaining half of the earth will not have sunlight. Fine. But see, if the axis of the earth is like this means it's okay. But axis of the earth is like this. So that means yes, only this part is having sunlight. So that is why North Pole is completely away from the sunlight. South Pole is completely towards the sunlight. So that is the reason. See, from the South Pole to North Pole, gradually the length of the day will be decreasing, and from North Pole to South Pole, gradually the length of the daylight will be increasing.